Our experiment aims to show the effects of surface area on heat transfer through baking cookies. This topic is applicable to different situations both in chemical engineering and in real life. For example, when designing an object you want to be able to heat up or cool down quickly, it's generally better for that object to have more surface area, and that's why radiators often have fins.
We decided it was best to test our experiment by baking cookie doughs in various geometric shapes. We used a convection oven for our experiment where we made sure to bake the cookie doughs on the same level of the oven during the same exact time. We made the cookie dough and formed them into their determined shapes the day before our experiment. This was to ensure that all the cookie doughs will have the same initial temperature after spending a night in the fridge. We also made sure that each dough was the same mass at 350 grams. On the day of the experiment, we put the doughs in the oven at 350 degrees Fahrenheit, making sure that the oven was thoroughly preheated. During the preheating, we made any necessary measurements to the geometric shapes, such as the length, height, or the radius. We then spent the next 20 minutes recording the temperature at the center of each geometric shape in 5-minute intervals.
Baking cookies relies on two heat transfer processes that occur in your oven simultaneously. Conduction occurs by molecular collisions and happens at the surface between the cookie dough and the baking sheet. High-energy atoms of the baking sheet collide with the bottom surface area of the dough, transferring heat energy. At the same time, a convection oven uses a fan to circulate hot air around the cookie dough. This motion of fluid transfers heat to the entire dough surface exposed to the oven air. We can also describe these processes mathematically using equations developed from Fourier's law and Newton's law of cooling. These equations describe conductive and convective heat transfer respectively, where Q is heat energy transferred into the cookie and A is the surface area of the cookie dough. Because these variables are directly proportional, more surface area of cookie dough means more heat is transferred to the cookie in the same amount of time, leading to faster baking. In our experiment, each cookie dough shape has a different surface area available for heat transfer. The sphere has the smallest surface area, meaning it takes longest to bake. As we increase surface area, more heat is transferred in the same amount of time, and we would expect baking times to continuously go down. The disc-shaped cookie dough should experience the most heat transfer because it has the most surface area accessible to the heating elements of the oven.
As mentioned before, we baked cookies, and in intervals of 5 minutes, we took the temperature of the various shaped cookies. All of the cookies initially started at 41 degrees Fahrenheit. At 5 minutes, the disc was the greatest at 69 degrees Fahrenheit, while the sphere was the coldest at 43 degrees Fahrenheit. At 10 minutes, the disc jumped up in temperature to 133 degrees Fahrenheit, while the sphere was the coldest at only 53 degrees Fahrenheit. After 15 minutes, the same trend followed, with the disc being the hottest and the sphere being the coldest. At 20 minutes, the disc was at 209 degrees Fahrenheit, while the coolest cookie, the sphere, was at 115 degrees Fahrenheit. That's almost a 100 degree Fahrenheit difference. We also created a graph to show the temperature change over time for each shape to give a better idea of the heat transfer for each cookie shape. Our experiment followed our original hypothesis that the disc would cook the most, the cylinder would have the moderate temperature, and the sphere would have the coldest temperature.
In the instance which this setup is not possible, like a high school classroom, some easy modifications can be done to use this concept for the demonstration of heat transfer versus area. To start, it isn't necessary to chill the cookie dough or make it as big as we did in our experiment. Our experiment included this in order to exaggerate the difference in temperature. In a classroom, measuring out pre-made cookie dough and making each shape, then using a large beaker and a hot plate would likely show the same outcome. Using a timer and thermometer, we recommend measuring the temperature every minute or so since the cookies will be smaller than ours were. But this allows a high school teacher to use our concept in order to demonstrate heat transfer versus area to students without the access to an oven.